Okay, so as you just heard from Orkan, um, I'm going to present kind of a story about why we think there's a reasonable case that we're actually seeing the expression of basal melting followed by advection of the melt up to the surface in northern Sputnik Planitia. Here's the list of authors, and I want you to, you'll probably not know who Robert Anderson, Bob Anderson is, or Gary Clow. They came on this project a few years ago. They're actually terrestrial glaciologists at the University of Colorado who have very deep experience in both experiment and theory relating to terrestrial glaciers. So make sure I do this right. Yeah, okay. So take a look at this pair of pictures. There's something very interesting, we think, going on in the northernmost reaches of Sputnik Planitia. Not in the mountains, but actually in the northern reaches, almost along the shoreline. You see these very interesting diffuse dark zones that seem to be associated with these linear features, these even darker linear features. And what we believe is that there's a case that the linear features may be extruding basal melt that's come up from beneath the glacier, and that it's darkening as it spreads out into these more diffuse features. So, all right, so I'm going to say a little bit about this. So here's a bit of Oliver's map, and we want to point out 5 things, 4 of which are on this chart, on some of the characteristics of northern Sputnik Planitia. First, the lateral flow patterns and the swirl flow appearance that we see in the images I was just showing you, and which are in that inset as well, indicate there's dynamics going on, and that dynamics has to be faster than the sort of few 100,000 year to million year convection cell lifetimes. Secondly, the softened terrain appearance that we see that's associated with all this, we think may indicate rheological properties in these specific places that are different than elsewhere in SP. Now we're going to introduce a little bit of terminology. So the discrete dark narrow features, which you saw, those are the linear features I was referring to earlier. They run tens of kilometers individually in characteristic length. And they typically follow the convection cell boundaries. Fourth in this list is that these linear features, the DDNFs, are characteristically surrounded by the diffuse dark regions that I showed you. We call them dark aprons. And they stretch up to 20 times the extent of the DDNFs. Finally, the colors of these dark features are not the same as the colors of the residues that we see, for example, in the mountains surrounding Sputnik. This appears to be something very different. So we don't believe these are tholins. There's something else going on. And so we hypothesize that the dark linear features and their associated dark aprons originate from basal melt of nitrogen ice beneath Sputnik. So let's talk about that a little bit. And what I want to point out first is that the darkened material that you see in both the linear features and the surrounding dark aprons, we think, as I said, are indicative of the upwelling of the liquid nitrogen melt. Now, terrestrially, not with nitrogen, of course, but with water in glaciers, when liquids like water or melted snow infiltrate dry snow, they are often seen to darken it. And in fact, this is a terrestrial image where just that kind of effect is taking place. There are 2 possible mechanisms that cause that, and then they both work terrestrially. One is the darkening can happen when the liquid fills the air spaces or the voids within the snow. This then reduces the amount of light that can scatter around because you have an additional absorber, and that causes the snow to appear darker. Secondly, the darkening can also occur because there are impurities in the liquid that impregnate the ice and that darken it for that reason. And one or both of these could be operating in the nitrogen of northern SP. So let's talk a little bit now about melt origin and the processes for that. So thick nitrogen ice acts as a thermal blanket, and Orkan didn't show this, but he's done calculations that demonstrate that it'll trap internal heat. And then grain growth via the dynamic recrystallization process that Orkan has been talking about reduces conductivity. And he just talked about that. But then that lower conductivity leads to enhanced insulation. And the enhanced insulation in turn results in basal warming. So you've got kind of a closed loop feedback that is aided by the fact that the basal pressure, meaning the overlying material down to the base, all the ice that's above it, in the case of Sputnik, which may be considerable with quite a number of kilometers, that basal pressure further lowers the melt point, and so can impurities. So we have a plausible case for getting to melt. In the paper that we're writing, we'll actually show that numerically. We're not there yet here. And then the melt is transported to the surface. So you get liquid at the bottom, that's the melt. The liquid nitrogen is buoyant relative to the dense cold nitrogen ice above it. Cracks, faults, or other pathways allow that buoyancy to find a transport path to the surface. And then when the liquid spills out on the surface, it will eventually freeze as it begins to spread out. And we don't know if this kind of process on Pluto is taking place episodically or on some more regular schedule, or whether it's in fact something that only happened once that created all these features that look so much like one another across northern SP. Line it up. Good.
I denounce you. Jeff says I have to denounce you. Anyway, so yeah, I'm glad you pointed out the idea that the northern flank is eroding, but it's also topographically low compared to the middle of the ice sheet, which suggests that it is eroding. Is it possible that this is just a representation of the ice sheet everywhere underneath it for the whole north, south, east, west of it? That this is just what we're seeing? Maybe I'm missing the point.
I'm not sure either of us follow. What is the this you're referring to when you say this is a consequence of the erosion? The darkening?
Yeah. The dark pattern, the mottled pattern, the gray areas, the dark lines, everything. And we're just seeing clean ice as if this was like a glacier that's been stripped off or something like that. And you're seeing the blue ice.
I think it's more likely that because it's eroding and there's a shorter path length from the base up to the surface, it makes it easier to get the melt all the way to the top.
Hi, in the Silvia Protopapa, back in 2017, when we published the quantitative composition maps of Pluto, we saw in the map related to the nitrogen enriched phase, the dichotomy between the north and the northeast and the bottom west of Sputnik, and show that there is this dichotomy perfectly correlates with the nitrogen subliming from the north, recondensing. This is the theory we put forth. Nitrogen is subliming from the north, recondensing to the south, leaving behind on the top part of Sputnik CH4. And there is also a change in grain size within Sputnik Planitia to that phase. Now, I'm wondering whether this sublimation process is also correlated to the description you are invoking or not.
So I just have one thought, Sylvia. If that erosion from the north with the transport to the center is taking place and you have impurities in the ice, then they'll be left behind like a lag deposit, which will further, enhance the appearance, just as we said.
Right, and exactly that was the idea we put forth, that CH4 is being left behind in these phases, and so that is what is responsible for the change in albedo between dark and bright.
Yeah, but I mean, it also follows the borders of the putative convective cells. So what's going on there with that? What you're saying is solely responsible. We should see darkening pretty much uniform across the
Not
directions.
necessarily. It depends on the scale of the processes, right? It could be that those lineations are showing a version of that process, but in an enhanced way because favored by the geology. I'm not sure. Just
I'd like to talk to you offline about this.
Sure.
'Cause I know they're going to pull a hook and we have to go. But I think that the association of the linear features with the dark aprons is something that our concept provides a natural explanation for, that I'm not sure gets explained if it's just sublimation and then plating out in the center.
We have time for one more quick question, and after we have to move on. So, but only one
Okay.
quick question.
Eeny, meeny, who's go?
Todd.
All right.
Oh, no. No, yeah, forget about Oliver. I'll take Todd's question. He's looking-
Right.
Sorry,
So,
Oliver.
so Todd Lauer, NORLab. Perhaps this was covered in Paul's and Sylvia's questions, but my memory of looking there is you have a large area, particularly close to the shore, where it's all swirly cream and coffee that's frozen out, but yet the cells, they don't really, cannot recall any flow patterns, drainage, pooling, bathtub lines or anything you might expect for thing coming up. Are these both the same thing or are they separate?
Well, remember the optical effects could be reflected in an extremely thin veneer on the surface that don't affect the big cells on a much larger length scales and depth scales.
I'm sorry, we have to move on. Sorry. Thanks again for the speakers.
Oliver, catch us offline.
Yeah.